Hello everyone. In the previous lecture, I told you how to select the most economically visible alternative concerning to the annual or the method in water resources. Today, I'm going to show you how to select the best option among other alternatives to construct a water structure, dam, or levee to mitigate flooding. In this lecture, I show you the application of benefit-cost ratio method in water resources. This is the third question regarding to economic analysis in water resources. This is very relevant question in hydrology and water resources engineering. A flood control district can construct several alternative control works to alleviate flooding. These alternatives include the construction of Dam A, Dam B, and a system of levee C. Each of these works can be built to function alone or together with any other or all other projects. Thus, we have the possibility of the following combinations: A, B, C, A, B, C, AB, AC, and BC. The life of each dam is 80 years, and the life of the levee system is 60 years. The cost of capital is 4%. Information on total investment, operation, and maintenance costs and average annual flood damage is given in the table. Which flood control undertaking is the most economical? As you see, all information is given for project ABC, C, AB, AC, BC, ABC. As you see, total investment cost is given in millions. For project A, the total investment cost is 6 million. For project B, the total investment cost is 5 millions. So, for annual operation and the maintenance cost, all data is given here in thousands. And also, average annual damage is given here in millions. This is called do nothing. This indicates the benefit of dam and the levee. So, depending on the information, you can estimate the best alternative. Okay? Then, to estimate or to select the best alternative among these three projects, we have to estimate capital recovery factors for each project. To estimate capital recovery factor, you have to press equal sign, then open bracket, click on interest rate times, open bracket, 1 plus I, close bracket, the power of n, close bracket, over, open bracket, 1 plus I, close bracket, is the power of n minus 1. Then the value of capital recovery factor for project A is 0.0418. For project B, we have to press equal sign. Then you have to take capital recovery factor of project A directly. This is equal. Interest rate in a service life of project A and B is equal. So you can take here. Next, I'm going to estimate capital recovery factors for project C. Like this, I times 1 plus I the power of this value n over 1 plus I the power of n minus 1. Then the capital recovery factor for project C is 0.044218. Then the capital recovery cost for project AB is equal with the capital recovery factor for project A. The capital recovery factor for project AC is equal with the capital recovery factor for project C. The capital recovery factor for project BC is equal with the capital recovery factor for project AB. The capital recovery cost of project ABC is equal with the capital recovery factor for project AC. Right. Next, depend on these capital recovery factors, we can estimate annual investment cost like this by multiplying capital recovery factors times total investment cost. Then you have to drag down this one. For each project, we have got the annual investment cost like this. To estimate annual operation and maintenance cost, we can divide its value by 1 million. As you see, this annual operation and maintenance cost is given in 1,000. So, to familiarize with this value or annual investment cost, as you see, it is provided in millions. So, to change the value of operation and the maintenance cost given in 1,000 to millions, you have to divide by 1 million. As you see, this one is 90,000. So you have to divide it by 1 million. Okay? You have to get like this. So for each project, you have to divide it by 1 million. You have to divide this value by 1 million to get annual operation and the maintenance cost. Okay? Then simply you can estimate total annual cost from these values, or by pressing equal sign on keyboard, then this value or annual investment cost plus annual operation and maintenance cost. Then this is total annual cost for project A. To get for remaining project, you have to drag down this value like this. Next, I'm going to estimate the benefit of each project. First, I'm going to estimate benefit of project B. The benefit of project B is estimated by subtracting 1.3 from 2. 1.3 is the amount of cost lost by flood damage. So 2 minus 1.3 is 0.7. 0.7 is the benefit of project B. To estimate the benefit of project A, we have to subtract 1.1 from 2. 2 minus 1.1. This 0.9 for project C. 2 minus 0.7. This 1.3 for project AB. 2 minus 0.9. 1.1 for project BC. 1 minus 0.5 for project AC 2 minus 0.4, 1.6. For project ABC 2 minus 0.25. This is the benefit of all projects. Next, I'm going to estimate the costs of each project. Already I estimated the cost of each project here. This is total annual cost for each project. So I can take from here directly the cost of project B is 0.289. The cost of project A is 0.341. The cost of project C is 0.365. The cost of project A, B is 0.63. The cost of project BC is 0.556. The cost of project AC is 0.62. The cost of project ABC or the last project is 0.933. Good. Now we can estimate benefit cost ratio from estimated values of benefit and the cost. To estimate benefit cost ratio, you have to divide benefit by cost, or 0.7 divided by 0.289. Then for remaining project, you have to drag down this value like this. Good. Then now we can estimate change of benefits from benefits. First, you have to take 0.7 here. Then it is easy to estimate change of benefits by subtracting 0.7 from 0.9 like this. Then you have to drag down for remaining project. Then you can estimate change of cost. This is cost. First you have to take this one. Then you have to estimate change of cost by subtracting this value from this value. Then simply you can drag down this value. Finally, you can estimate change of benefit, change of cost ratio by dividing 0.7 by 0.289. Then you can drag down this one. So as you see, the highest value is 16.44 for change of benefit per change of cost, right? And the benefit cost ratio is, the maximum benefit cost ratio is 3.56. Therefore, project C is economical based on BC ratio. This is all about today's lecture. Don't forget to subscribe and like my YouTube channel.